Welcome back to part 2. This is the video where I will go over Q equals mc delta T calculations, some examples, and how to experimentally find out values of Q and enthalpy change. So in part 1 I went over some definitions to do with enthalpy and some diagrams and how to construct them. So next part of enthalpy are calculations. So Q equals mc delta T. This is an equation you'll need to know when working out heat change and enthalpy change. So, if we just define what each one means. So Q equals the heat energy, M equals the mass, so this may be the mass of the solution or the mass of the solid, depending what you're using. And for that, you have to refer maybe to the density of it, because water, for example, is 1 gram per centimetre cubed. So it's easy if you have 50 centimetres cubed, it weighs 50 grams. However, some things may be more dense, so you get some solvents that could be 1.08 grams per centimetre cubed, or something that could be ridiculous like 10 grams per centimetre cubed. So you have to make sure that you know the mass. And in an exam paper A level, they will usually give that to you, except for water, which you should know as being 1 gram per centimetre cubed. So C is the specific heat capacity, which in this case is 4.18 joules per gram degrees C, and that's usually for water, and again that will be given to you. So delta T, as you remember, the delta stands for change in the last video, and T stands for temperature. So it's the change in temperature, and this is in degrees C. So you're looking at the change in temperature in degrees C. So if they give it to you in degrees Fahrenheit or degrees Kelvin, then you need to convert it into degrees C. But most likely at A level they will give it to you in degrees C. So now we know what these are, we can now do some examples. So, example 1. Calculate the heat energy required to raise the temperature of 225 centimetre cubed of water to 20.0 from 20.0 degrees to 100.0 degrees. And significant figures plays a role here. As you can see, each one has 3 significant figures. So, the equation is Q equals mc delta T, or when I did A levels, our teacher would like to say mcat. So, calculate the heat energy. That means we're calculating Q. So that's what we've got to calculate. We have mass. As remember I said, water is 1 gram per centimetre cubed. We have 225 centimetres cubed, meaning we have 225 grams. So that's our mass. Specific heat capacity will usually be given to you, which is 4.18, and in the next example it is given to you. Joules per gram per degree C. And then delta T, the change, and you need to be careful on the symbol here. So if it went from 20 degrees down to 10 degrees, delta T would be minus 10, but in this case it's 20 to 100, so it's increasing by 80.0 degrees C. So put those values in. So Q equals mass 225 times by C, 4.18, times by delta T, which is 80.0. So therefore, when you put that all into a calculator, that comes out as 75,500 joules, which is the same as 75.5 kilojoules. Now, like I said, you have to be careful with significant figures because that isn't the calculator value. Here you've got 3 significant figures, 1, 2, 3. Here you've got 3 significant figures, and here you've actually got 4, but the minimum is 3, therefore you give it to 3 significant figures. Hence 75.5 kilojoules, or 75,500 joules. So, example 2. How much heat energy is needed to increase the temperature of 55 grams of water from 25 degrees C to 28 degrees C, the specific heat capacity of water is 4.18 joules per gram per Celsius. So feel free to pause the video and have a go yourself, and then I'll work through it afterwards. So again, it's asking for heat capacity. So you're working out Q. Just write the equation down again, it's always helpful to do. So mass here, they've actually given you the mass this time, so 55.0 grams. And you've got C, again, which is 4.18 joules per gram per degree C. And then you want delta T, which in this case is 3.6 degrees C. Again, look at significant figures, because it's only, or decimal places, it's only given to one decimal place, therefore I can only give that to one decimal place. So we put that in, so Q equals 55.0 times by 4.18 times by 3.6, and when you put that in the calculator, that gives you a value of Q being 830 joules. Now again, that's not the value, that'll be on your calculator, but again you're looking at significant figures here. So delta T is only one decimal place, and because it's then single digit before the decimal place, 3.6 is two significant figures. Brilliant. So now, on to the experimental way of finding Q or H. So if you want to find out the enthalpy change of reaction or the heat energy change, there is a way to do it experimentally, and it's using a calorimeter. So what you do, for example, if we were going to react hydrochloric acid and magnesium carbonate. So if you've done this before, you'll know that CO2 is given off, there'll be some water and some magnesium chloride, and that carbon dioxide bubbles, and you can put it into an acid. So this is solid and this is aqueous, meaning that you can fill this up with the acid and just tip this solid in. So what this container is, what this vessel is some way of stopping heat from being lost from the system. So the easiest way to do this, an easy, cheap way I should say of doing this, is using polystyrene cups, like typical coffee cups that you might get. Obviously in big labs, big industrial labs, they'll use something a bit more sophisticated than a polystyrene cup, but it's quite a good insulator, so you can use that. You can make a lid as well from polystyrene to stop heat from escaping out the top. As you know, heat rises. And as you remember, the equation is Q equals mc delta T. Mass, again, you can weigh the volume of HCl, or if you know the density, you can just use that. So if you know, say the density again was 1 gram per centimetre cubed, you put 50 centimetres cubed in, you know it's going to be 50 grams. You've got your mass of magnesium carbonate, and if you weighed out, say, 3 grams of that, you'd know that the total is then 53 grams, the 50 of HCl and the 3 of magnesium carbonate. So that's how you work out your mass. Specific heat capacity. Now that's something that will be given to you, as it may not be the same as water because you're using an acid. So that's just a given value, or something you can, if you're at home, you can just research values on. And then delta T, how you'd work that out. So you get this polystyrene cup, you've filled it with acid, you've weighed out your solid in like a weigh boat or something like that. You would then open the lid, tip that in quickly, shut the lid, and stir with a stirring rod. Before you would have done that, you would have taken a note using this thermometer of the temperature, so the start temp. And then what you'll do, as you're stirring, the reaction is happening, you'll watch the temperature go up and up and up until it hits a peak. So for example, if the start temperature was 25 degrees C, room temperature, and then it peaked at 31 degrees, so you know it's gone up 6 degrees. And again, it's the peak, because the reaction will happen, it'll go up and up and up, reach say 31. and then the reaction will start slowing down, it will start dropping, and it will stay around 29 for a bit. It might drop down to sort of 26, and then it will eventually return to 25 after time. So it's the peak temperature you're looking for. So you've now worked out mass, you've been given C, and you've now worked out delta T from this experiment. I mean, you can just put it all into the equation and work out the value of Q. And it's as simple as that. It's quite a straightforward experiment and cheap to make. Thank you for watching this video. I hope you enjoyed it. I hope it's been helpful. Subscribe and share and like for more videos. Let me know if there's any videos you want me to do on topics I haven't covered yet. Just put it in the comments below or send me a message and I will do that ASAP. Thank you.